Let's do some examples using the sampling distribution of a proportion. We'll start with a simple one that some variation of this comes up in pretty much every stats class there is. So according to the manufacturer, 20% of Skittles are red. So we could find P, our population proportion, is the proportion of all Skittles that are red. And we know we've just been told, like literally right here, that that is 0.2. Now suppose we have a bag of 243 randomly assorted colors, assuming it's completely random. P hat is the proportion of reds in your bag. So P hat is going to be a random variable. Each of these bags could have a little more or a little less than 20%. So if you get a question like describe the distribution of P hat, you would write something like P hat is approximately normal with mean mu equals 0.2 and standard deviation equals the square root of 0.2 times 1 minus 0.2 divided by n, which is 243. And we actually should calculate that if we're going to do any calculations with it. So if I put this here, standard deviation of p hat equals, and then if I calculate that, in Excel I just do SQRT, 0.2 times 1 minus 0.2 divided by 243. So we get this 0.02566. There we go. So it's approximately normal, so we can do calculations using the normal model. Like calculations like find the probability that a bag contains over 25% red candies. So we're going to use GeoGebra with mean 0.2 and sigma equals 0.02566. So we click over to GeoGebra. We just set this up. The mean is 0.2, 0.02566. Probably won't let me enter that many decimal places. We'll have to round to 0.026. So find the probability it contains over 25% red would be this portion here. Here's 0.24, 0.26. So 0.25 and more would be over from there. So do upper tail, put 0.25 in here, and get this 0.0272. So the probability is 0.0272. So you can interpret that as 2.72% of bags of this size will contain 25% or more red candies. And there you have it. It gets a little confusing because you have multiple percentages in the same problem, so you kind of need to keep straight what you're doing. This is always the area or probability box or something. And this, since our horizontal axis is the percent of red candies in a bag, this, you enter here your percent of red in a bag, whatever that happens to be, and this gives you the probability of that happening or the area under the curve. Don't mix those two up. It can be tough to tell, especially if the numbers are similar.